Hello, welcome to this FastChat sponsored by Legrand. I'm Rebecca Herold, CEO of Privacy and Security Brainiacs SaaS Services and CEO of the Privacy Professor Consultancy. I started my career as a systems engineer at a Fortune 200 corporation. There were some huge concerns we were trying to meet because we were trying to get as close to 100% uptime as possible. Now, there were a lot of issues necessary to consider to meet that goal, but they were often overlooked by many organizations, including using high performance power outlet technology, protecting from power spikes, monitoring for efficiency, and having security capabilities to protect and maintain the power source and keep unauthorized access to those settings protected because those could be very harmful. These concerns are even more important now than ever before. And the increased complexity of data centers increases the risks related to those concerns. Well, today we're going to discuss a few of these issues and how important uptime, availability, reliability of power sources are to meeting operating systems goals. Our guest today is Calvin Nicholson, Senior Director of Product Management at Legrand Data, Power, and Control Division, which includes server, technology, and Raritan brands. He is responsible for overseeing product strategy and product management for PDUs and other related products. Welcome, Calvin.
Thank you, Rebecca. I appreciate it. You definitely have a great background for this call.
Because of my background and where I started as an engineer, I'm wondering, what are some of the power and power monitoring challenges that data center operators face today with this complex environment we're in?
Yeah, and it really is a complex environment, there's no doubt. And I think that as you look to IT being broader, whether it's edge or storefront or cloud or whatever, you've got to really operate and perform in all these different environments. So what we do is we provide the tools to distribute the power, of course, but also to control on off for reboots and things, and then multiple levels of the power quality monitoring. So our goal is to really give our end users the information they need to avoid problems before they would ever happen. And that could be a lag in power, that could be a number of different things, a brown, any of these other things we can really look at both at the in-feed level, so the A and B feed coming into the PDU, and at the outlet level. So maybe at the outlet level, you want to be more concerned with harmonics or things like that. Maybe at the in-feed level, you're just looking at overall, what is the capacity? So I don't exceed the rated capacity of the PDU as an example. So we really give the customer the ability to monitor, control all the power, environmentals, in fact, too, for if it gets too hot or humidity is too high or whatever, and another number of other sensors. So we're really giving them the peace of mind to manage all those things within the data center cabinet. And really in the cabinet, if you look at the overall infrastructure, that's where about 40 to 60% of all the power in the data center is used, is really all those devices racked and stacked in the cabinet itself.
Yes. And you talked about our complex environment. Now, I work with a lot of hospitals and medical systems. Talk about edge devices, and patients' lives depend upon having those powered up, right? So that's probably a really important, just one example of a really important example of why this is so important to keep that power going.
Yep, absolutely. We've seen a lot of that with some of the HIPAA rules, the digitization of all the documents, and a number of things. Yeah, so that actually is a big growth area that we're seeing right now on the IT side of things.
Well, can you explain some of the recent advancements in cabinet rack PDU technology?
Yeah, so the PDUs themselves, like I said, have kind of been that last point. The PDUs are typically redundant, right? There's an A and B and feed of power. In a perfect world, in a Tier 4 data center, those would be from two different, completely separate power grids, but that's not always true. And then once you bring that three-phase power into the PDUs, we distribute it to the devices as single phase. And that's where we kind of take control with the monitoring, with the outlet control. Some of the newer features are harmonic distortion. There's a lot of switch mode power supplies, whether it's in the servers themselves, whether it's in the storage, whether it's in the network switches. They often create harmonics as an example. So we can look at that, see where you're losing efficiency, see where there's heating, see where there's other problems being created, and then give you that information back. We're also starting to do a lot of diagnostics. So if you have a server issue, let's say there's a short of a power supply or something like that, and it blows one of the branch circuit breakers on the PDU, we can actually help you by telling you which device had the problem. And also that helps with the diagnosis of getting that branch circuit up and going quickly as well. And if the customer hasn't done a coordination study, in some cases that can blow the upstream breaker, and you may be running all your devices off one power source for that period of time. So just a couple of examples of how we're kind of making, using the technology today, more accurate technology, and giving our customers more information to run their data center.
Calvin, you mentioned before about the selective coordination, the testing and so on. How does that become more important with all these new technologies and new complexities? Or maybe you could mention something about the importance of those?
Absolutely. And Rebecca, that's really one of the finer points. Customers will have a problem with the server device. It will actually blow the breaker on the branch circuit, and then they'll lose the whole PDU, and they really don't understand why. Well, the reason is the breaker at the PDU and the breaker at the RPP, the remote power panel, are not selectively coordinated. Their trip curves overlap, and therefore when the branch breaker blows, the upstream breaker blows, which can be very dangerous because now you've got one PDU supporting your whole IT load. And that's where you really get into if your devices, your redundant devices, were wired properly, and if you have enough power on that one PDU to support the whole load. So in theory, that could have a daisy chain of events, and you could even lose the whole cabinet. So it's a very critical point. There's no doubt, and one that's not talked about, and like I said, a lot of people just don't really understand.
Well, that sounds like a very severe type of problem to have to deal with. What are some of the other types of problems that intelligent PDUs with advanced metering are able to solve then today?
And that's a good question. And as a follow-up to the selective coordination, if you lose one of the infeeds, one point I should mention, both on the Pro 4X from ServerTech and the PX4 from Raritan, is that we redundantly power the controllers on the unit. So as long as one of the PDUs has power, you still have all your communication, you still have access to the device, you still get your alerts and alarms. You can still talk to that PDU through its intelligent network card. So I probably should have mentioned that in my last answer. But anyway, the problems we're solving is really the main problem that's with any data center. And that's really uptime, right? So you want to minimize your problems. You want to get power data, whether it's sags or surges or any other type of power quality problem, and get alerted to that. Understand where you're having your issues. Understand what the maximum capacity is, whether it's of a branch or of the whole PDU, and look and have alerts and alarms for those thresholds, so that you don't overload a branch or you don't overload a PDU and have downtime issues with that. We also do power factor calculations. We do crest factors, current and voltage just in general, just a number of other power factor measurements that we really do add a new accuracy level. So we're going from a 1% device to 0.5% device. We're also changing our A to D sampling where we can actually capture the image of the waveform when these devices happen. So if there's a problem and a server shorts and it blows the branch circuit breaker on the PDU, we can capture that waveform as a point in time, and you can understand exactly what happened to your current and voltage when you had that problem. So not only will it tell you it's outlet 13, you need to go look at that server, but it'll give you diagnostic information that will allow you to make decisions. We're also doing some new min-max power stuff too. So it's very interesting if you are installing a new server and you understand the load of the cabinet at that point, but you probably need to know what the load of that cabinet was, both temperature and power-wise, 6 months ago or a year ago, whatever your worst case was, then to understand, do I really have enough power available in that cabinet? And do I have enough cooling capacity where I can safely install that server? And we actually track the min-max loads on those devices to where you can look at that information and make those kind of decisions directly from the interface of the PDU itself.
As you described that, I was thinking how this could be also very beneficial for forensics investigations, particularly after like distributed denial of service attacks that bring down, overload and then try to bring down a network. So yeah, that sounds very important and very useful.
Yeah, absolutely. Because we're if you get the right device, we can measure at the outlet level and therefore at the device level. So you can see what the load is on the server, right? And it's interesting for a couple of reasons. One is that the unit's going to use, a server is going to use a fair amount of power just sitting there idle. So you can track that power and see that that device is doing no useful work. And therefore, it may be a zombie server that you want to look at because it's not being accessed. But to your point, if there's an incredible load on that server, and it could be something you understand if the peak of your business is on Black Friday or whatever it happens to be. But in general, if you had a denial of service attack like that, you would see that max power load go up on all those devices as well. So it's an interesting point.
I'm wondering, how does this technology then fit and work within an existing data center infrastructures? There's a lot of legacy data center infrastructure still being used out there. So how would this technology fit in and work with those?
That's an interesting question. I mean, the devices we're powering are the devices we're powering, right? So newer servers may have a more efficient platinum power supply, maybe a higher power factor, things like that. They may use less energy. But in general, we're going to monitor no matter what the device is. And then the PDU itself fits into your ecosystem. So we have open APIs that can talk to building management systems or DSIM systems. We've actually just introduced the Redfish API, both on the PX4 for Raritan and the Pro4X for server technology. And some of those features will even be retro to some of our older products. So Redfish API, another very industry standard way to monitor. And it's kind of do the work once, deploy many, in the sense that once you've implemented the Redfish API, no matter what device you connect, if it talks that API, you don't have to redo the work. And then we have standard alerts and alarms. A lot of them are through SNMP and regular tools that people are familiar with as well. So we'll fit into that ecosystem. There's a web GUI where you can see the min-max stuff I talked about. You can see the waveform capture. You can look at all the different power parameters we provide. So there are just a number of different ways that we can get that information to the end user.
Well, thank you, Calvin, for all this valuable information today. I learned a lot, and I know our listeners did as well. And thank you, audience, for joining us on FastChat. I'm Rebecca Herold from Privacy and Security Brainiacs SaaS Services. Please join us for our next episode of FastChats.
Thanks, Rebecca.